Hi, we are here with Chapter 6, Section 6, Proving Angles Are Congruent, and we'll be delving more into writing out proofs. A couple things as a reminder: an old definition, a postulate or axiom, is a statement that is accepted without proof, and then our new information, which is a theorem. A theorem is a conjecture that is proven, notice we're going to prove it, that is proven true by using definitions, properties, postulates, and other theorems. And remember, the properties are the ones that we were introduced to in the last section, I believe, section 6-5. Okay, important theorems that come up in this section. First one is the vertical angle theorem. You will be allowed to, if you want to, abbreviate it either VAT for vertical angle theorem, or VAC for the words that go along with it, and that is that vertical angles are congruent. So that's where the VAC comes from. Notice this sentence has been written just as a statement. If we wanted to state it as a conditional, we would say, you can hold on a second here. Okay, here's the theorem written out as a conditional. You might want to stop the video and copy that down. Okay, applying that same theorem to this particular picture, you would write, okay, here's the same statement applied to this particular picture. And you'll notice I wrote it out for angle 3 and angle 4, but it could also be written out for angle 1 and angle 2, which are the other pair of vertical angles in this picture. Notice also I put here the reason we get to make that statement is because vertical angles are congruent. We justify our statement with this particular theorem. Okay, the next theorem on board is that all right angles are congruent. That one is going to become a biggie as time goes by. So here's the sentence for that. Here's the sentence, or the theorem actually, written out as a conditional. If two angles are right angles, then the two angles are congruent. Now, you can also write a statement applying to this particular picture, so we'll go ahead and do that. Okay, you'll also see for this particular picture, if we know angles A and angle B are right angles, then we can say angle A is congruent to angle B because all right angles are congruent. There are a couple more theorems in the book on pages 122 and 123. I do recommend that you take time to read them. They're nice to know, but you don't necessarily need them. You will not be expected to apply them. On the bottom of the page here, we have the linear pair postulate. This has been introduced previously. We've used it in different problems, but it's going to come in handy for proofs. And it says, if two angles form a linear pair, then they are supplementary. You can also say, and this may be a shorter way to write it in proofs, that linear pairs are supplementary. Okay, so we're going to stop here and go on to page 2. Okay, here we are on page 2, and we are proving the vertical angle theorem. So in our picture, we're given angle 1 and angle 2 are vertical angles, and we're trying to prove that angle 1 is congruent to angle 2. Okay, well, I can't mark in a picture that angles are vertical, so I'm just going to go ahead and start my proof. So your first statement will almost always be you're given. Easy enough. Your second statement, well, I need to prove angle 1 and angle 2 are congruent, and I can't use the theorem yet because I'm trying to prove it. So I look at the picture and I ask myself, what other relationship do I see happening with angle 1 and angle 2? Well, I notice that angle 1 and angle 2 are both supplementary to angle 3. So angle 1 is supplementary to angle 3, and angle 2 is supplementary to angle 3, and our reason is linear pairs are supplementary. Now, once I know that angles are supplementary, almost always I'm going to go from that sentence to the equation that applies to that. Well, being supplementary means that the measures add to be 180, so that's my next step. And my reason will be, go ahead, stop the video, take a guess at what you think it is. Okay, you're back, and the reason would be definition of supplementary angles. Notice I'm abbreviating a lot of words, and that's okay. You are also welcome to abbreviate the words or use symbols for them. Okay, now we go on to step 4 where we find out, well, what's my connection then? And take a look at this here. 1 plus 3 equals 180. 180 equals 3 plus 2. So I can say 1 plus 3 equals 2 plus 3, and that is, you could either put transitive property, or you're welcome to use substitution. Either reason would be perfectly acceptable in that situation. Then I say measure of angle 3 equals measure of angle 3. Well, why can I say that? Well, pretty much just because I know it always has to be true because of reflexive property. And then the next step, well, if you go back to step 4, here I was adding angle 3 to both sides. I know angle 3 is equal to itself, and so I can subtract away angle 3 and get left with angle 1 equals angle 2, and that's the subtraction property of equality. Now, I like to put in the reflexive property. For you guys, you can, if you were to skip this property and jump straight to step 6, I will find that acceptable. So let's go ahead and just write next to this. This is an optional step. At which point, now that I know angle 1 is equal to angle 2, that's great, except if you look back up at the top of the page, we were trying to prove 1's congruent to 2. So how do I get from the measures being equal to the angles being equal? Well, the way that I do that is by using the definition of congruent angles. And we have just completed another proof. All right, let's move on to the next page. Okay, for our next proof, we are being given that angle 1 is supplementary to angle 2, 1 and 2, and we're also being asked to prove that angle 2 is congruent to angle 3. So sometimes what I like to do is I will just put a little dot in my paper to show that those are the two angles I'm trying to prove equal to each other. I'm not going to mark them equal because, again, we don't know that for sure. We're trying to prove it. And so, and again, there's no way to mark that something's supplementary. So at this point, I start with my givens as usual. Angle 1 is supplementary to angle 2. Great. And then you have choices of where you can go next. My option is, well, if I'm trying to prove something about angle 3, I probably should say something about angle 3. So I look at my pictures and I look at where angle 3 is and I ask myself, well, what can I say about angle 3? Well, it's right here next to angle 1. They're forming a linear pair, and therefore I know that angle 1 is supplementary to angle 3. Reason? Linear pairs are supplementary. Okay, well, I have these lovely sentences, but it's usually more helpful to have equations. So, angle 1 is supplementary to angle 2, and angle 1 is supplementary to angle 3. Well, when things are supplementary, I know they add up to be 180 degrees. So, maybe stop the video and see if you know what to write next. Okay, so we applied the definition of supplementary angles to write that 1 plus 2 equals 180 and 1 plus 3 equals 180. Well, we've seen this before in previous examples, so if they both add up to equal 180, then what's the next thing I can say? Stop the video and take a guess. Okay, here's our statement number 4. Here's our reason number 4. Now notice as you're writing out your proofs, I hope you're being good about lining up your statements and your reasons. You always want to. So notice how my reason here was a little bit long. So I dropped down a little bit to put step 5, and the reason is going to start directly across from it. Okay, so at this point, I know 1 plus 2 equals 1 plus 3. I know that I'm trying to prove 2 and 3 are equal, these guys. So, who needs to go away? That's what I asked myself. Who needs to go away? Well, I need angle 1 to go away. Can I make angle 1 go away? You have two options. You can, you may decide to use reflexive property or you may not. Why don't you try to write out step 5 and step 6? Okay, I opted to go with the reflexive property to show that angle 1 is equal to angle 1. Again, that's your optional property. You may have chosen to skip that. But once I subtract away angle 1, we're left with angle 2 equals angle 3. Again, we're close, but that's not exactly what we wanted. We wanted them to be congruent, so I go to step 7 and I convert to congruence, and my reason for that is the definition of congruent angles. Okay, we have completed all the proofs we're going to complete for today's video. I'll see you in class where we'll be completing the rest of the 6-6 packet. All right, have a great day and see you in class.